Good afternoon, everyone. Hope you guys are all doing well. Hope you guys are having a good weekend. I'm just gonna give a couple more seconds just in case anybody else joins. But yeah, hope you guys are all doing good. If there's anybody new today, if you're joining the classes for the first time, just a quick intro. My name is Daniel. I'm a GCSE and A-level maths tutor. And throughout the last couple of weeks, I've just been running a couple of online classes for you guys as you guys have got your exams coming up. So yeah, we had one yesterday. Went through a couple of questions and then, oh, someone's joining. Cool. Yeah. Went for a couple of questions and then today we're just going to go over some more questions. And yeah, as I said before, the way I've picked the questions is largely based on the Edexcel Sandboard, just due to the fact that majority of us are on that. But as we know, there's a lot of overlap. So if you're not on Edexcel, for an AQA, OCR, MEI, etc., then I'm sure it will be beneficial for you anyway. 4 marks on Tuesday, absolutely, bro. You guys are all going to get 4 marks on Tuesday. But yeah, cool. So what I'm going to do is I'm going to share my screen. And then I've picked up a couple of questions that I think would be good for us to try today. So yeah, we're going to go through this one first. So yeah, this is obviously trigonometry, harmonic identities. So having a look at this one, guys, what do we think about it? If we see this on Tuesday, what are our thoughts? Are we happy? 0 if we're not happy. Put a 10 if you can't wait for this to come up. And then we'll go through it. I'm just going to just let a few more people in. Okay, 5, 6, 9, fair enough. Okay, well, let's go through this together because I feel like this is something that always comes up. So we're going to start here. Move this out of the way, that's for later. Gonna put this here. Okay, so we got this here. Let me just see the chat. Cool, I can see 6s as well. Anyways, so part A, this is not too bad. We know how to do this. So let me just put this here. So it says express 1.5 sine theta minus 1.2 cos theta in the form r sine theta minus alpha. So what you're doing here, you're just using the compound angle formulas for sine, aren't you? All right, so we'll put 1.5 sine theta minus 1.2 cos theta, minus 1.2 cos theta. And we know that this is equal to, because it says in the form, right? We know, so just 1 second as well, I'm just letting more people in. Okay, cool. Okay, I think that's all okay. Now continuing, because it says in the form, we know that this is going to be equal to that, right? So r and then sine theta minus alpha. Now we know according to our identity, this is just going to be, now if I remove the r, it's going to be sine theta cos alpha. So I'm just letting people in as I'm explaining. So if I stop and pause, you know why. But yeah, sine theta cos alpha and then minus cos theta sine alpha, isn't it? Right? And then remember, this is that one there. So if I put the r, if I expand the r, then I'll just have an r in each term within that. So let me just grab that out, put r there. So it'll be like this so far. It'll be an r here, and then it will be sine alpha here. Yeah? And then 1.5 sine theta minus 1.2 cos theta. And all you're doing now is you're just equating coefficients, aren't you? So remember, we've got a sine theta here. We've got a sine theta here. So the coefficient is 1.5. And if this is the exact same thing, this must be equal to that. Yeah? So we're going to say that r cos alpha is equal to 1.5. And then we're going to do the exact same thing here. Listen here. We've got a cos theta here. We have another cos theta here. The coefficient would be, now they both have a negative sign, so I can just ignore it, doesn't matter. 1.2 here. And this is r, right? Sine alpha. They both have a negative sign, so I don't need to account for that. If I do, it will just cancel anyway. Is that clear? That's why I'm not doing it. But just let me know if that's making sense. Yeah? So we're going to say r sine alpha is equal to 1.2. Now we know what we do here. We need to get alpha and r. So we're going to, we divide to get tan. So I'm going to say r sine alpha over r cos alpha, which I know the r's will cancel, right? Sine over cos is tan. This is tan alpha. And we know that this is equal to 1.2. Sine alpha is 1.2 over 1.5. Yeah? So we get this here. And then obviously to get alpha, we're just going to take the tan inverse, aren't we, of that. And let's see what that gives us. 1.5. Put this in my calculator. Get my calculator up. It's here. Am I in radians? I am. Yeah. Radians as well, just to make sure it's in terms of pi. Radians, perfect. And then put this in. Tan inverse of 1.2 over 1.5. This is equal to 0.674, blah, blah, blah. And it's set to 3 decimal places, isn't it? Yeah. So 0.675. 0.675. That is alpha. Now to get R, well, we just use the Pythagorean identity, don't we? We're going to square this one, R squared. We're going to square the top one, R squared cos squared alpha. And then we're going to square this one and add them. R squared sine squared alpha. And then this must be equal to 1.5 squared plus 1.2 squared. And then now we take out the R squared. This gives us cos squared plus sine squared, which you know is 1. So we have this here, 1.5 squared plus 1.2 squared. And then we now say, well, that's just R squared. So R will just be equal to the square root of that, wouldn't it? So I'll just put that into my calculator, 1.5 squared plus 1.2 squared. We just check to make sure we're okay. This is, I've just checked the message. This topic is harmonic identities. You know those modeling questions where you have to use this expression here and they give it to you in some sort of model. Yeah, this is just harmonic trig identities. Yeah, for somebody that just asked what topic this is in the chat. So just put this in now. Take the square root. So the square root of 1.5 squared plus 1.2 squared. And this gives us 1.921 to 3 decimal places, isn't it? That will give me 1.921. Let me just double check that again. Perfect. Yeah. So R is 1.921, alpha is 0.675. All happy with that? Oh, does it want the exact value for R? Let me see. Give the value of R and the value of alpha. It doesn't say exact value. Somebody put in the chat that this says that they wanted the exact value. It doesn't say that, so I think it's fine like this. But if it did say that, then obviously yeah, I'd put it in third form, wouldn't I? 3 root 41 over 10. But it says the 3 decimal places for both. So I'm assuming that means R and alpha. That clear? That okay? Yeah. Okay. Good stuff. All right. Now continuing. Now this is the next part that they always throw at us, right? How do we find these ones? So let's read it. It says the height h meters of seawater at the entrance to a harbor on a particular day is modeled by the equation h is equal to 3 plus 1.5. I've seen this before. Plus sine pi t over 6 minus 1.2. I've seen that before. Yeah. Pi t over 6 between 0 and 12 for t. Yeah. Where t is the number of hours after midday. Using your answers to part A, calculate the minimum value of h predicted by this model and the value of t to decimal places when this minimum occurs. So remember with this question, they always give you this part A, you rewrite it in the format of r sine theta minus alpha, and then they put it into this model, right? What you're doing with this one is you're using what you've done in part A to replace this, because if you think about it, right? If I write this here, I always do this. I'm going to put this here. I've got 1.5. I've got 1.5 sine theta minus that, right? And then in the model, I've got this. Like this here, yeah? I've got this here. Now, the only difference between these two is the angle, right? Now, in part A, what did we work out? We figured out that this was equal to 1.921, because that was r, sine theta minus the alpha, which was 0.675. Yeah. So therefore, do we agree that this here, well, the only difference here is I'm going to say, well, theta is just equal to pi t over 6. So therefore, I'm going to say, well, this is just equal to 1.921 sine of pi t over 6 minus 0.675. Do we agree with that, guys? I'll wait for you guys to say yes or no, just so that we're all okay with that. Yeah? Good. Yeah. That's all you're doing with these ones, right? The whole point is that you have this sort of expression in terms of sine and cosine, and you can rewrite it in terms of only one of the trigonometric expressions, and that will make it easier for you to maybe find maximum points, minimum points, so on and so forth. That's the whole point of this topic. Yeah, you have some sort of weird expression, you're going to rewrite it in terms of one trigonometric function, and it's easy to do. Yeah. So continuing. Well, if that's the case, then I can simplify this model, can't I? I could say, well, originally it was this. Yeah. Put this here. Da, da, da. Originally it was this, right? Well, now I know what this part is, right? This part, in terms of what we did in part A, it's just going to be h is equal to 3 plus, and then what I'm going to do is I'm going to replace this with that because it's the same thing. Yeah, it's going to be 1.921 sine of pi t over 6 minus 0.675. Yeah. Do we need to add the 3 too? Yeah. So what I was doing, so thank you very much for that, Lucy. What I was doing, I was just breaking it down into parts, just so we can see what the relationship is between part A and part B. But of course, yeah, you bring it back all together. So this is your final model for H. Yeah, cool. So that's fine. Now the question says, using your answer to part A, calculate the minimum value of H predicted by this model. That's the first part. And we need to find the value of T when this minimum occurs. Okay, so now I have this here. I need the minimum of this, right? H min. Now, when we see minimum in A-level maths, straight away, your head can go to differentiate, make equal to 0, blah, 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 so on and so forth. But when you're doing this type of question in particular, there's no need for that. They don't want you to do that. What you need to recognize is that all you have here is you just have a sine graph, right? That's been stretched vertically. Because, for example, you know, the general format is going to be r sine theta minus alpha, right? If I was to draw this, well, this minus alpha just means that it moves to the right by alpha, right? So it doesn't affect how high or low it goes, right? Remember, normally the sine graph is like this, like this. If I have an r there, then it will just stretch up. If this was 1 and minus 1, right? Then it will just stretch up to r and negative r, right? So always remember that when you're doing this one. Yeah, the max and minimums of this type of expression here will be r and negative r. So since they want, what was it? They want the minimum, right? Okay, yeah, they want the minimum, right? So looking at this here, well, I have 3 plus, and then I need the minimum of this, don't I? This entire thing here, right? Well, this entire thing, remember, it will go from 1.921 and then it will go down to minus 1.921 for sure, right? So therefore, I can say that, well, I'm just going to have a minus 1.921, right? And to be fair, I can do it like this just to make it a bit more clearer. Remember, you could also do it like this as well. You can just say 3 plus 1.921, right? And we know that this function of sine, right? This function of sine has a minimum point at -1, right? Which is why I've got this here. Does that make sense, guys? Yeah? Make sure all okay? Okay, cool. So I'm just going to finish this and then I'm going to go back. I've got a couple of questions about part A and B, but I've seen your questions. Don't worry. Yeah. I'm just going to finish this very quickly and I'll go back just to summarize everything. Yeah. So now we've got H min is just going to be equal to 3 minus 1.921. 1.921. This will equal 1.079. Yeah. Perfect. So H min is 1.079. And then now we need to find the value of t at when this minimum occurs. Now remember, well, what you can do, just see the chat, man. Yes, yeah, the minimum occurs when sine is -1. Yeah, because we have h is equal to 3 plus some number times sine. So to find the minimum of this, we need to find the minimum of sine, don't we? Right? Because that's the only part of the function that is variable. The 3 is a constant. The 1.921 is a constant. The only thing that varies that can change is the sine. So we need to find the minimum of that, which is -1. So that's why we plug it in. Yeah. Anyways, we found the minimum height at which this occurs. Now we need to find the value of t. Now remember, we're doing a trigonometric equation. We need to solve it. Remember our boundaries. It's between 0 and 12 t. So t is in between. Is it inclusive? Doesn't really matter, to be fair. No, it's not. Anyways, like this here. Just always remember this, especially when you're dealing with trig. So we need to find the value of t when this occurs. Now, what you can do is you can say, well, we can select the height occurs, the minimum height occurs at 1.079, right? So you could just make your function equal to that, right? 3 plus 1.921 sine of that. But what you can realize, right, is that, remember what I said before, the part of the function that is affected, which determines whether or not it's the minimum or the maximum, is sine. We know that that occurs when it's -1. So what you could do, you could move the -3 over, blah, 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 and then divide by 1.921. What you'd get, though, is you just get sine of pi t over 6, right? Minus 0.675. This will just equal -1, right? Because that is where it occurs anyway. But you can do it this way. You can just make it equal, move it about, you get the same thing, but you can just go straight to this. Is that clear? Does that make sense, guys? Trying to make sure all okay with that just before I continue. Yeah? Good, 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 good. Okay, cool. And then just quickly as well, the relationship between part A and part B, for anyone that asked, remember, the whole point of part A in these questions is you're rewriting this thing here, right? In this format here. That's the whole point of this topic. What I can see in part B is that I've got the exact same thing here in yellow. The only thing that's different is the angle inside. So whatever I get for part A, the only thing different here is theta. So I'm just going to replace theta with pi t over 6. So that is why I put this here. Does that make sense? Yeah, good stuff. Yeah, good. All right. So now, let's continue. Now we need the value of t where this occurs. But remember, t is between 0 and 12. So let's take the sine inverse of that. Pi t 6 minus 0.675 is equal to -1. So sine inverse of that. So 1. Sine inverse of that is -1. This gives me minus pi over 2, yeah? Now remember, minus pi over 2 is clearly a negative number, but to be fair though, there's a lot going on before we get t anyway, so maybe if we move this around and make t the subject, it could potentially be positive, right? But just check though. Well, what I would do as well, what do I know about minus pi over 2? That's just 3.14 divided by 2, which is negative 1.57 or something like that, right? That there, if I move the minus 0.675 over, this will still give me a negative result. So it can't be this value. Yeah, does that make sense? That's the stuff you want to do when you're dealing with these types of questions and you're looking for which intervals you're looking for, the range. Does that make sense? Yeah. So I need to go to the next one, don't I? Yeah. Okay. So just quickly. So remember, we're solving an equation between 0 and 12. T has to be positive. So when I do the sine inverse, I get minus pi over 12, minus pi over 2, right? Now, because I'm looking for t, I need to rearrange this, blah, blah, blah. If I rearrange this, for example, I'm going to add on, the first thing I'm going to do is I'm going to add on the 0.675, yeah? 675. This is still a negative result, right? Now, if I times by 6 and divide by pi, that's not going to change the sign of it. So it can't be that one. So what I'm saying is that what you say to yourself is, okay, it can't be that one. Sine is periodic. It repeats itself. We need to go to the next one. Yeah? That clear? Exactly. I'm getting the next one because it doesn't satisfy the range that we're dealing with. Yeah? Good. Cool. So the next one, well, it repeats every 2 pi. So I'm just going to add 2 pi to that to get the next one where it hits -1. And that would be, well, that's just 4 pi over 2, which is 3 pi over 2. Is that correct? Let me just double check. No, that is correct. -1.5 plus 2 is, yeah, that's fine. Cool. So we've got that there. So now let's try this one. This is clearly going to be fine. So it's going to be pi t over 6, right, is equal to, and it'll be 3 pi over 2 plus that 0.65, right? 0.675, sorry. And then I'm going to divide by pi and times by 6. Divide by pi times by 6. So that those will go like this here. Yeah? And then if I put this into my calculator, see what I get. So it's going to be 3 pi over 2 Put a fraction here. 3 pi over 2. And then plus 0.675. Going to divide by pi times by 2. So I get that there. Let me just make sure that's all correct. You see, times by 6. Oh, sorry. Thank you very much, guys. I was thinking what's going on here. Yeah, that's why you guys are helpful. Thank you very much. So if you see me doing stuff like that, thank you very much. Times by 6. Perfect. Perfect. Yeah. So we get that there. T is equal to 10.2. What did they want it to? What did they want it to? 2 decimal places, right? So T equals 10.29. Yeah. 10.29. And to be honest, it's between 0 and 12 for sure. For sure, the next one is going to be way over 12, isn't it? So we know that this is definitely correct. Does that make sense? Yeah. So you're just always gauging what it is and everything. Cool. Cool. This question here, this part B is 4 marks. Now we're going to go into part C, which is this here. Let's have a look. So we've done that. Let's continue. So it says now for part C, find the nearest minute. Find to the nearest minute the times when the height of the seawater at the entrance to the hub is predicted by this model to be 4 meters. Okay, well, our model is this thing here, right? This is our model for the height of the seawater in the hub or whatever, right? If it's predicted to be 4 meters, then we're just going to replace h with 4 and then solve, right? So so for the second value of sine, don't you do pi minus theta? Yeah, that's when it's so remember like this here. What was it? Our one was when it was -1, like this here. This is what I was looking for. -1 here. And then the next one after that is there, isn't it? Yeah. Which is this is at minus pi over 2, like there. And then this here will be at 3 pi over 2, isn't it? Right? And then if you're looking for when you do pi minus theta, that's when it's positive, yeah, because it will reflect here. Does that make sense? Yeah, so because it was -1, I don't need to do that. I just go here and then I just see what the next one is. Is that clear? Cool, 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 cool. Okay. So looking at the next one now, we need to find t when h equals 4, right? The times as well, the times. What does that indicate to me? That there's going to be more than one value of t. So potentially we'd have to do that. Yeah. Anyways, let's see. We've got 4 is equal to 3 plus 1.921. 1.921 sine of that there. T over 6 minus 0.675. And then obviously we're just going to, I'm going to do 4 take 3 divided by that. 4 take 3 over 1.921. And then this will equal sine of whatever that is. T 6, 0.675. So let me put this into my calculator, see what it gives me. Give me a 4 minus 3. 4 minus 3 divided by 1.921. This gives me 1,000 over 1921 or blah, blah, blah. Yeah, I'll leave it as a fraction. 1,000 over 1921. Yeah, and then this is equal to that. So we're just going to take the sine inverse and see what we get to. 0.675. Now remember, our range for t is between 0 and 12, isn't it? Yeah, so if I take the sine inverse of that, it will be I'll do it here. It'll be pi t over 6 minus 0.675, and this will equal the sine inverse of this here. I'll do this here. So it'll be the sine inverse of answer. This gives me this here, yeah? 0.547 blah, blah, blah. 0.547, what is it? 509. I'll do it to 6 decimal places, yeah? Now, remember, there's going to be multiple values of t due to the fact that it says find the times, not the time, right? And obviously, it's trig, it's sine. How do we find the other values of sine? Well, we can do, it's positive. So we're going to just do pi. To get the next one, it's going to be pi minus the angle. So pi minus that, whatever that is, 57509. And then obviously to get the next one after that, we're just going to repeat it. We're going to just do plus 2 pi, aren't we? right? So the next value would be whatever that is, right? 0.547509 plus 2 pi, sorry. And then the next one for this one will be the same thing. Yeah. So you're just going to do a couple just to make sure it's all okay. Yeah. But anyways, I'll do it in steps. So the first one, remember, where was t again? T is between 0 and 12. So let's do the first one here and see what we get. So this one here, this will be t is just equal to, if I rearrange this, it will be that 0.547509 plus 0.675 over pi times by 6, not 2. Don't know where I got that from before. But yeah, let's do this and see what we get. You find the second value of sine by doing, when it's positive, you do pi minus the angle, right? Which is why I've done that there. Yeah. Let me just quickly put this in. So 0.547509 plus 0.675 divided by pi times by 6. This gives me 2.34 blah, blah, blah. Yeah. So that's one value. That's between 0 and 12. That's fine. So I'm going to say t is equal to 2. I'll just do it to 5 decimal places. 2.33482. 33482. Yeah. Now this one here, the next one will just be that t is equal to whatever that is. So let me put this into my calculator. So just to be quick as well, I've got that value there. Let me just delete this to get the next value of pi. I'm going to delete that. So that's my value, right? I'm going to do pi minus that to get whatever the next solution is. Pi minus that. Does that make sense? And then because this one here is 2.5 blah blah blah, I'm just going to put it here. Yeah. So it becomes a 2.594084, and then plus 0.675 over pi times by 6. And then I'll get this here. T's range is between 0 and 12. Yeah. So we got this here. So put this here, and then I'm just going to plug this in and see what we get. So let me just make sure I've got that here, aren't I? Yeah, perfect. So I'm just going to put this in. So it's going to be answer plus 0.675 divided by pi times by 6. And this gives us that there. Yeah. 6.243 and blah, blah, blah. 24349. Yeah. So these are values of t. Let me just see. Why are we using two values? The reason why we're using two values is because it may not be 2. There could be more, right? I'm going to check. Remember, the range is between 0 and 12. The question says find to the nearest minutes the times. So more times than 1. When the height of the seatwell at the entrance is predicted to be modeled by 4 meters. Yeah. So t ranges between 0 and 12. I've got these two, right? What I would do, just check one more just to make sure. I'm pretty sure it's these two, but just to do one more, you could just do, well, for example, that 0.547, or you could just adjust the range at the beginning, but it doesn't matter. So put this here plus 2 pi, that there. Now, if I add that and I divide that by pi times by 6, this is going to be way bigger than 12, isn't it? But let's just do it anyway. So plus 0.675, right? We divide by pi, we times by 6 here, 14. Yeah. So the next one is too big. So these are the only two values. Does that make sense? T was between 0 and 12. These are the only values of t between 0 and 12. Is that clear? Exactly. In some regions of the world, the tidal rate is very drastically, so you get bottles of tea. Cool. So yeah. So yeah, it says find to the nearest minute though. Remember, what was t in? T was in terms of hours, wasn't it? It said something about hours. It did number of hours after midday. So we're just going to times these two numbers by 60 and we're done. Yeah. Times by 60 and see what we get. Blah, 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 blah. So I'm going to do that one. I've got this. Now I'll do this. 2.3482 times by 60 is equal to 140, right? To the nearest minute, that's 140 minutes. right? 40 minutes. And then this one here is going to be 6.24349 times by 60. It's going to give me 374.6375 minutes. That's the answer. Makes sense, guys? We're all okay with that? These questions take so long. Yeah, good stuff. Good stuff. So how many marks is this altogether? This was about 3 plus 4 is 7. 7 plus 6 is 13. 13 marks in an exam. Yeah, this is a good question. Okay. You have to go now. No worries. I'm gonna post this right after, I think. Yeah. I'm gonna post this right after the class. So I'll definitely post it today anyway. So if you need to go, no worries. It's gonna be on YouTube very shortly. But yeah, cool. We've done that one now. Now we're gonna go into this one. We're gonna go into this one here. Now we've got this here. Now looking at this one, I'm sure some of you have seen this before from Edexcel. How do we find this type of question here? Implicit differentiation. Put a 0 if you don't want this to come up. Put a 10 if you think this is super, super easy. How do we find implicit differentiation? Rip this page out. Nah, you're not ripping no page out. You're gonna do everything. I can see lots of 10s. Yeah, good, good, good. Anyways, let's make a start. So it says figure 4 shows a sketch of the curve with equation x squared minus 2xy plus 3y squared is equal to 50. We need to show that dy dx is equal to y minus x over 3y minus x. So this one here is very, very straightforward. Let's do it super quick time. Yeah, 3y squared is equal to 50, right? Now we're going to differentiate. We want dy dx. We need to differentiate with respect to x. So this one here will just become a 2x. And then this one, there's a minus here. How do I differentiate this one, guys? Somebody tell me in quick time. Thank you very much, Alex. Product rule. Yeah. So we need to say, well, I've got 2xy here. I'll just do it here very, very quickly. 2xy. I'll say this is u. I'll say this is v. I'll write here actually. U equals 2x. V is equal to y. U dash is equal to 2. V dash is equal to. Can somebody tell me, please? Is it 1? You've all frozen? I thought you guys got 10 in this. Exactly, exactly. Dy dx, yeah? Dy dx. We're differentiating a function of y with respect to x, right? We need to use the chain rule, which is why it's dy dx, yeah? So therefore, it's just going to be v u dash plus u v dash, isn't it? So this will become here. This will be u v dash, right? Doesn't matter which way you do it, because it's plus. U v dash is going to be 2x dy dx, like this here, and then plus these two, 2y. And then plus this one here, we're differentiating a function of y with respect to x. We need to use the chain rule. So differentiate with respect to y first, 6y, and then we multiply by dy dx, don't we? Yeah? Now, remember, this 50 here is a constant. This goes to 0. So now we've got this. All we're doing now is we're making dy dx the subject. So let's do that very quickly. So we're going to get 2x minus 2x dy dx minus the 2y plus 6y dy dx is equal to 0. So if I move everything with I'm going to keep everything with dy dx on the left, move everything without dy dx to the right. This will just be, and I'm going to put the positive term first. So it'll be 6y dy dx minus 2x dy dx is equal to, I'm going to put the y first because it's going to be positive on the right, 2y, and then this 2x will be minus 2x here. And then clearly now, if I factor out dy dx like this, I'll get 6y minus 2x here is equal to 2y minus 2x here. And then if I divide now, I'll get this. I'd get 2y minus 2x over 6y minus 2x. And then they wanted it simplified with the constants, isn't it? Y minus x, 3y minus x. All of these have a common factor of 2. So we can just say y minus x over, that will go to 3y minus x. That clear? Anybody have any questions on that? Or this is just super easy. These questions, part A's are easy, yeah? And remember, even though they're so easy, Don't skip any steps. I know, for example, I know you guys probably did it super quick time. You're in an exam, it's to show that question, just put every step there. Yeah, cool. That one's fine. Now this one here, part B, this is something that can come up a lot, which is what I wanted to do with you guys. It says the curve is used to model the shape of a cycle track with both X and Y measured in kilometers, right? So this is a cycle track, okay? The points P and Q represent points that are furthest west and furthest east of the origin O in figure 4. Using part A, find the exact coordinates of P. So having a look at this one, guys, what are our thoughts on it for part B? Put a 0 if you're looking at this, we can have no clue what to do. Put a 10 if you know exactly what to do. These are super easy. So I can see 4s, I can see 10s, 7s, 10s, 4s, 8s. Good. Overall, maybe like a 5/6. All right. Now, just a very quick one because this type of question can come up in a multitude of different ways, right? Now, I'm just going to show you a graph quick. This will be very quick, right? If I do an axis like this, right? And then if I draw a curve like this, right? Right? Let's just say I've got this here, right? Now, the highest point right here, right? What is the gradient at this point? Can somebody tell me in super quick time? Exactly, it's 0. But why is it 0 though? Because the tangent line at that point is horizontal, isn't it? Yeah. So, whoops, I need that actually. So it's a horizontal tangent, yeah, the highest point. Now, what does that mean? We have vertical lines, don't we? Yeah. So if you think about it, if I was to, for example, if I was to do this here, and I'll copy this picture, and I paste it here, right? And let's say I was to rotate it anti-clockwise like this, yeah? Now, remember, when it was the highest point, right, the tangent line was horizontal. Now, if I look here, do we agree that the furthest north, never east, sorry, I forgot my side. The furthest west point, right? The tangent line is vertical now. Do we agree with that? Yeah, exactly. Yeah. So let me just put this out. Yep, exactly. Good. So when it says it's asking us for the furthest west and furthest east, right? Our tangent line is vertical. So remember what that means though. Yeah, you have dy dx, right? Now remember from GCSE y2 minus y1, right? Over x2 minus x1, right? If the tangent line is horizontal, right? There is no change in y, is there? Which is why we make it 0, because the numerator is 0, right? X2 over x1, x2 minus x1, this is 0. This is because we have a horizontal tangent, yeah? So the numerator is 0. If the vertical line is, if the tangent line, sorry, is vertical, then there's no change in x. There's no change in this thing, the denominator. So in that case, we have to make the denominator 0, yeah? We have dy dx here. And if it's a vertical tangent, then we just make the denominator 0, right? The difference in x, there's no change in x. So we have this here, right? We have this expression for dy dx. Dy dx is equal to 3y minus x over, no, it was the wrong way around, sorry. Let me put this here. Y minus x over 3y minus x, yeah? Over 3y minus x. So because the tangent line is vertical, there's no change in x. So we have to make the denominator 0. Does that make sense, guys? Is that clear? Trying to make sure we're all okay with that. Go wait for everybody to say yes or no. Yeah? Yeah, good stuff. So now, continuing, it's asking us to find the exact coordinates of point P. So whenever you do this type of question, you've got this equation here. You're just solving a quadratic simultaneous equation. Because what I can do now is I can say, well, I'm going to say, well, x is just equal to 3y. And then because I'm finding the points of P, right? Then I would just plug it back into here. That's all you're doing with this one. You're just plugging it back into the original equation and then solving, yeah? So let's do this quickly, huh? Got this here. So it will become, it will become, if I plug that in there, it will be 3y all squared, minus 2 lots of 3y, and then y plus 3y squared is equal to 50. Now, tidying this up, this will give us 9y squared, and then this one here will give us minus, and then this will be 2 times 3 is 6. This is 6y squared plus 3y squared is equal to 50. And let me just check the chats to make sure. Why is the denominator 0 for west? Because that's where the tangent line is vertical, right? The denominator is 0 because there is no change in x at this point. So your fraction for dy dx is the denominator is 0. Yeah. If for anybody, I'll explain that again in the chat maybe as well. I'm just going to finish this off quick just due to time. But yeah, got this here. Now this is super easy because there's not even other variables here. It's just, there's not even other terms. It's just all in y squared. 9 minus 6 is a 3. 3 plus 3 is 6. This is just 6y squared. This is 6y squared is equal to 50. Now that means that y is equal to, we divide by the 6, and then we're going to take the square root, and obviously we do plus or minus, don't we? So now we've got the two answers for y. Let me just simplify this in my calculator. So square root of 50 over 6 is equal to 5 root 3 over 3. Yeah. So y is equal to plus or minus 5 root 3 divided by 3. Now remember, x was equal to 3y. X was equal to 3y. So what does this mean? That just means that x is going to equal 3 times the plus or minus of 5 root 3 over 3. So therefore, x simplifies to just, what's this? The 3's will cancel. Plus or minus 5 root 3. So x is equal to plus or minus 5 root 3. Y is equal to, we'll just double check that there. Sorry, yeah, that's fine. Oh yeah, that's fine. Plus or minus 5 root 3 over 3. Yeah, is that clear? Yeah, good stuff. So now we've got our values for x and y. Yeah, now the question asked us, what did it say exactly? Find the exact coordinate of P, the point P. Now remember, there are two vertical tangents, right? The exact coordinates of point P is one of them. Now looking at the graph, clearly this is in the third quadrant where x is negative and y is negative. So it has to be the negative pair of our answers. So the coordinates of P, so therefore coordinates of P will just be negative 5 root 3 and negative 5 root 3 divided by 3. Make sense, guys? All good? Yeah? Okay. Also remember as well, when you're doing this, they can ask you this in loads of types of ways. They could say, find the exact coordinate where the tangent line is parallel to the y-axis. That is the exact same thing. They could say, find it where it's parallel to the x-axis. That's a horizontal tangent. So then you make the numerator 0. Does that make sense? So just be aware of that they can bring this up in different ways. Yeah. This way, they contextualized it and they said furthest west, right? But sometimes they can just be a bit more, algebraic and just say, for example, find the points where the tangent line is parallel to the y-axis, which will mean a vertical tangent too. Yeah. Okay. And then for 1 mark, then it says explain briefly how to find the coordinates of the point that is furthest north of the origin. You do not need to carry out you do not need to carry out this calculation. Well, that's fine, because remember what we did at the beginning. Furthest north, right, would be the maximum height. And we know that the tangent line is horizontal there. So what we would do in this case is, instead of making the denominator 0, we would make y minus x 0, the numerator. Right? Y minus x 0 will give us y equals x. Then we plug this back into here, blah, blah, blah. Yeah. And then obviously you'd get two solutions, because obviously you'd have a max height here. You'd have a max height, a lowest point there. So you'd get two solutions, and obviously you'd pick the positive one because they asked for the coordinates of Q, because it's furthest north. Is that clear? This question okay? Yeah. Easy stuff. Good. Cool. All right. Now, these questions take such a long time, and so annoying that they take up so much of the lesson. Okay. Now we're gonna do this one here, a modeling one. Let's see how we go on with this one. Just see the chat. Exactly. You do not need to carry out this calculation. Exactly. Just write a little statement about what you would do. Yeah. Okay. So Quick. Shout out to one of my students because he gave me this question to do for you guys. He said, Daniel, you got to do this one. So having a look at this one, what do we think about it? 0, if you're looking at this thinking, what is going on here? Please, my mental health. Or 10, this is super easy. Throw this to me on Tuesday. I need this. This is what I need on Tuesday. Okay, -10. 10, 0, 5, 6. No worries, guys. No worries, guys. So remember, if any of you joined last week when I did the cone one, it's kind of similar. Yeah. Now, let's read it and see how we get on. Yeah. Okay. It says figure 4 shows a right cylindrical water tank. Okay. The diameter of the circular cross section of the tank is 4 meters and the width is, sorry, and the height is 2.25. Yeah. Water is flowing into the tank at a constant rate of 0.4 pi meters cubed per minute. What is that telling me? Before I even, when I'm doing this type of question, that there, what is that? Can somebody tell me? What is that showing me? Remember the units of measurement. Meters cubed is volume, per minute is, what is that? So it's, let me see the chat. Rate of change, exactly, yeah? dV dt, in other words, yeah? So I'm going to just put here dV dt. So far, I haven't finished the question. I've got it going in. This is 0.4 pi. Yeah. Now it says there is a point T at the base of the tank right here. If there's a tap, then that means the water's coming out. When the tap is open, water leaves the tank at a rate of 0.2 pi root h meters cubed per minute. Well, that's the same units of measurement though. So they can't both be dV dt, right? So what do we do here? What do we do here? Remember, we've got water going in and there's water coming out. So what would be the overall flow of water? What would be the overall rate of change of the volume? Exactly. We take the difference between them. Thank you very much, Ethan. Exactly. Yeah. So it's going to be, so from that there, we can say dV dt, right? You could just think of it as the rate of change is going to be the water going in, right? Minus the water going out. That will give you the overall rate of change. The water going in was the first part, 0.4 pi, right? And then minus that part there, 0.2 pi root h. So this is dV dt, yeah? Okay. Now, what does this say? It says show that at time t minutes after the tap has been opened, the height h meters of the water in the tank satisfies the differential equation 20 dH dt is equal to 2 minus root h. So remember with this one, the main thing for me, right, is here. Remember, this is just a constant, right? My job is to figure out what dH by dt is, isn't it? Yeah. So what you want to do is remember the chain rule. Remember the chain rule that you learned at the beginning of year 13. dy dx is equal to, we have a variable u that connects y and x together, dy du times du by dx, right? Because these cancel here, right? So now, looking at this one, we need the h by dt. So I know for sure it's going to be dh divided by something multiplied by that same something divided by dt, because those question marks will cancel. This is going to be dh dt, yeah? If it was my job to find dh dt, I'd be unemployed. Anyways, yeah. So what do we think the question mark would be then? Based on the variables in the question. Remember with these modeling types of questions, what variables do you have? What derivatives have you found? Exactly, it's dv. Clearly, we even found it before we even answered the question, right? It's dv, it has to be. What else is it going to be? Yeah. So therefore, I'm going to put dv here like this, right? Okay. Well, then that tells me, okay, well, I know what dv dt is. I worked out here. So I'm going to have dh by dt, right? dh by dt is equal to dh by dv, right? Multiplied by dv dt, which I now know is 0.4 pi minus 0.2 pi root h. Yeah? So for me, that tells me then I have another job. I need to figure out what dh by dv is somehow. Now, I've got dh by dv. The only way that can happen is that if I have a formula that connects V and H together, doesn't it? Right? That's the only way I'd be able to get a derivative for H in terms of V and blah, blah, blah. So you say to yourself, okay, well, where can I get a formula that connects V, which is the volume of the tank, and the height, right? Well, clearly, we're just going to use the volume of a cylinder because it's a cylindrical tank, right? So remember, well, we've got this here, the volume, or let me do it here actually, I'll do it sequentially to be fair. The volume is, what's the volume of a tank? Pi r squared H, right? Okay. Now, we've got this here. The problem is though, that this is in terms of R and H, right? So we need to figure out something for R, or if it was a similarity one that we did last week, then we need to figure out R in terms of H. But we've got a cylinder, right? Yeah. Remember the question that we did last week, right? This one is even easier, to be fair. What did we do? 2nd of June, right? Remember this one here, right? We had to find an expression for the radius because it was changing, wasn't it? Right? Because it's a cylinder. Yeah. Sorry, it's not a cylinder, it's a cone, right? So it's going so the circle at the front is getting smaller. We had to find an expression for that in relation to the height. This one is easy because it's a cylinder, right? The radius is just going to stay the same. So R will just equal 2. Thank you very much, Kylan. Does that make sense, guys? This is even easier than the one we did last week. Yeah? So therefore, we're going to say R is equal to 2 based on that. Let me move this here, by the way. We know from here, I'll just put R is equal to 2. So we're just going to plug in 2. And then we're just going to get, if I say R is equal to 2, then that will just be V is equal to pi 2 squared H. And then that's giving me V is equal to 4 pi H. Yeah, 4 pi H. And then now we have V in terms of H. Yeah? Does that make sense, guys? We all okay with that? Anybody have any questions so far? Is this all okay? It's R is equal to 2. Remember, R represents the radius, right? We have a cylinder here. The diameter is 4, right? Can we see? Yeah? The diameter of the circular cross-section of the tank is 4. The radius is half the diameter. So it's 4 divided by 2, which is 2. That's why R equals 2. Does that make sense for anybody that was asking? Yeah? Good. All right. Now let's continue. We've got V is equal to 4 pi H. So differentiating V with respect to H, right? Because we have V here, it's in terms of H. dV by dH is just equal to 4 pi, right? Because remember, 4 pi is a constant, so it disappears. Yeah. I'm confused. Is H the height of the cylinder, or is it the height of the water? H is the height of the water, isn't it? Yeah. H is the height of the water, because remember, we're modeling the water going into the tank and there's a tap at the bottom. So H is the height of the water. That's what we're modeling. Yeah. I hope that's clear for anybody that was asking in the chat. And yeah, so we've got dV by dH is equal to 4 pi. And then okay, I've got a couple of questions. I'm definitely gonna get through it. Let me just finish this. Yeah, don't worry. I'm seeing your questions. Don't worry. Yeah. So dV by dH is equal to 4 pi. Now remember, we need dH by dV. So we're gonna take the reciprocal. dH by dV, right, will equal 1 over 4 pi for sure. Yeah. So therefore, dH by dt, which we know was equal to dH dV, which we now know is 1 over 4 pi. Yeah. Times by this there, 0.4 pi, 0.4 pi, and then minus 0.2, and then what is it? Pi root H. Yeah. Now we're gonna expand. Remember, this is a show that question, by the way. So always have in mind what you're trying to get to. Forgot that, to be fair. Let me put this on. So remember, show that questions always have a goal. Yeah, show that questions are the best, because once you get them right, those 5 marks or however many marks a show that is, you know that's it. They can't even say anything. That has to be correct, because you got it. You did algebra, you got what they wanted. So satisfying. Anyways, expanding this now, what happens here? Well, the pi's will cancel. Then this becomes what? What's that? 0.4 divided by 4. Put this in here. 0.4 over 4 is equal to 1 over 10. So this becomes 1 over 10. And then minus, the pi's will cancel again. I'm going to do the 0.2 over 4 now. right? Which is just going to be half of that, no? Because that's 0.2, right? Yeah, that's just going to be half of that because it's just, yeah, 1 over 20, 1 over 20, right? And then we've got the pi's cancel, and then it's got root h here. And this is dh by dt. Now remember, what do we want? We want 20 lots of dh by dt. So we're going to times by 20. If I times by 20, dh dt, this will equal, well, times that by 20, that will give me 20 over 10, which is a 2. The 20 will cancel there, minus root h, and you're done. Come on, guys. If this comes up to on Tuesday, this is, we're chilling, we're breezing, for sure. Yeah? It's the same thing each time. Does that make sense? Yeah? Satisfaction, exactly, exactly. Good stuff. Yeah? Now, continuing, 3 marks, 3 marks, okay. Now this one here, it says, at the instant when the tap is opened, t is equal to 0 and h is equal to 0.16. Use the differential equation to show that the time taken to fill the tank to a height of 2.25 meters is given by this here for 2 marks. So this one, it's a little bit of a different format to what you're used to when you're dealing with it, but it's okay. So remember, we've got this differential equation here. Got this differential equation here. Put this here. Okay, put this here. Now we need to use that to show that we get that there. So it says to show that the time. So I need what t is. Yeah. Now we've got this here. Put this here. What shape formulas do we have to remember from GCSE? Because I'm just confused with the formulas. Okay. Okay. Yeah, for sure. Your questions, I'm gonna definitely go through them. Let me just finish this off. Okay. Now, obviously, we need t. They said, don't we? Yeah. I remember they've told us, right, that we know that t equals 0, right? H is equal to 0.16, yeah? And then the time taken to fill the tank is 2.25, yeah? So at a later time, it goes to 2.25, yeah? At some later time. So let's get t. We separate variables, it's just differential equation. So I'm going to do 20, and then I'm going to divide by this. Remember, we have to divide by this whole thing to get get the whole thing in terms of h. We need to divide by this. So we're going to get 2 minus root h here, right? And then that dh is fine, like this. And then we're going to times up by the dt, aren't we? Yeah? And then now, remember, we do integral signs like this. And then now, to be honest, remember, this is, technically speaking, you're just dealing with a function in terms of the variables t and h, right? So because it's t equals 0, 0.16, which is wherever this is t equals 0, right? It's increasing, but at a slow rate, isn't it? Because there's a water leaking from the tap, right? It's going to go up to 2.25 eventually, yeah? So all you're going to do here is, well, so if I want t, right? Well, integrate that. That will be t, like this, because this is just 1t, isn't it? Yeah, that will be t. And then, to be honest, you just literally just put the limits on, and that's it for 2 marks. dh, and that will be where is it? What was it? Between oh yeah, 0.16 and 2.25. Yeah, 2.25. So they can ask you, they can ask it to you like this as well. Yeah, where they ask you to just find an expression for the integral. Yeah, or for one of the variables. Yeah, that all clear? That okay with that? And even if this is a bit weird to you, it's 2 marks. It says use the differential equation. You want it all in terms of h, right? Just separate variables as you normally would, and you just put in the limits. Yeah, yeah, good stuff. Good stuff. All right. Now, part C, which is 7 marks. 7 marks. Okay. Let's read it. It says using the substitution 2 minus x all squared or otherwise. So they're saying we're giving you some help, but if you think you're that guy, you're that girl, you do what you like. Find the time taken to fill the tank to a height of 2.25 meters. Yeah. Give your answer in minutes to the nearest minute. Yeah. Okay. So this here is fine. Let's get this here. Okay. So we're just basically figuring out what t is. So let's just read the question again, just very quickly here. Right? We know from part B, use the differential equation to show that the time taken to fill the tank is this. This is the time taken to fill the tank, this integral here. And in part C, they're asking us to find the time taken to fill the tank. Yeah? Well, that means we just need to solve this integral here using the substitution, doesn't it? Yeah. So we're just going to do that now. Let me put this in. Where is it? So we got this here. Hold on a sec. Okay. So it's the integral of 2.25 and then 0.16. And then it was 2, was it 20 or 2? 20. 20 over 2 minus root h dh. Yeah. Now we're just using the substitution. H is equal to 2 minus x squared. So having a look at this one, guys, what are our thoughts on it? Is it not just 20 ln x? No. No. Remember, when you're dealing with this one, right? It's think of it as this. It's 7 marks. It's not going to be a quick one, right? And remember, when you're integrating fractions, the way you get ln x, right, is if you inspect the denominator. Remember, if I do not f dash. If I have f of x on the top, and the numerator is f dash of x or some constant of it, some adjustment of it, this is ln of f of x, right? So if I look at this denominator here, if I differentiate this, 2 minus, well, this is h to the half. If I differentiate this, this will just go to minus a half h, and then what's 1/2 minus? That's going to be minus 1/2 like this. If the question was this, minus a half h to the minus half on the top, and it was that on the bottom, right? The numerator is a derivative of the denominator. So therefore, it will be the ln of that. We can't do this here. Does that make sense for anybody that put ln? Is that clear? Yeah? Okay, no worries, no worries. For anybody that has to go, sorry, I always overrun with these lessons. If you have to go, no worries. It's going to be on YouTube. Yeah? So yeah, cool. No worries. So just be careful with that. Yeah? Anyways, let's just finish this off. I know you guys have a lot of other exams and studying to do. But anyways, continuing. So yeah, we've got this here. We've got h is equal to 2 minus x squared. So first things first as well, I've got a square root of h here. If I square root h, right, this is just going to go to 2 minus x, isn't it? Yeah. So therefore, I'm going to have a 20 so far, like this. And then it's going to be 2 minus the square root of h, which is now 2 minus x, like this, so far. And then I've got this dh here. Now, remember, what you want to do when you're dealing with h, and you need to get it all in terms of x, right? Because this is the substitution. We need to differentiate, don't we? So we have h is equal to 2 minus x, right, squared. Now, how do we differentiate this? This is just the chain rule. dh by dx, the 2 will drop to the front. 2 times 2 minus x, times that will go to a 1, right? If I times by the inside derivative, right, this is going to give me a minus 1, so I have to put a minus at the front here. So therefore, this is dh by dx, isn't it? Yeah? So now, remember, I need dh, don't I? Right? If I get dh, then dh should just be equal to minus 2 minus x times dx, isn't it? And I'm just going to replace that in my integral. Now, let me not forget my limits because I need to change these two as well, don't I? Yeah? So I've got this here. This will be 20, and then it will be 2, or you know what, I can tidy this up now, to be fair. Let me tidy this up. 2 minus 2, that will cancel, and then it will be plus x. This is just x on the bottom, isn't it? Yeah? And then dh is that. Now, remember, what I can do is I can just say, well, I've got the dx here. I've got the dx here, and then this part, I'm just going to put on the numerator, aren't I? So it's just going to be times by that minus, I'll expand it now, to be fair. That will become a minus 4. That will be minus 4, and that will be a plus 2x, isn't it? Yeah? 2x here. Does that make sense? And that's 2.25 over 0.16. Yeah? So all I've done, these two things in yellow are the exact same thing. I've just simplified it a bit more just to make things easier. Yeah? Okay. Now, let's tidy up a bit more and then change the limits of integration, and then I'm sure it will be okay. We've got minus 18. When we expand that, then we're going to have a plus 40x all over x. And then this is the x. Now remember, we need to change these limits of integration. Now remember, the original integral was all in terms of h, wasn't it? Yeah? So we need to change these limits into x. Yeah? Yes. I was actually going to send this to you guys on OneNote. So I'm going to send a link. I'll explain after. So let me just do this quick. But yeah, cool. So got this here now. What have I got? We've got h is equal to 2.25. And then remember, h is equal to that. 2 minus x all squared. So if I want to get x now, I'm going to square root both sides. If I square root both sides, I have the square root of 2.25. This will equal 2 minus x. So therefore, x is just equal to 2 plus the square root of 2.25, isn't it? Yeah. Put this in here. See what I get. Square root of 2 plus 2.25. 2 plus square root of 2.25. This gives us 7 over 2. Let me just double check. Is that okay? 7 over 2. Let me just double check that. That goes there. Yeah, that looks fine to me. Is it 2.25? Let me just make sure. Yeah, that's all fine. That's all fine, right? Yeah, yeah. Oh, wait. Let me just double check. H was equal to that. Yeah, that's fine. That's fine. Let me just double check. Oh no, sorry, it's not. It's minus, isn't it? This is a minus. This is a minus because that will go there and that will go there. Guys, you guys didn't even say anything. Okay, so this should be a minus, shouldn't it? Yeah, that should be a minus. It's 1 over 2. Yeah, so x is equal to 1 over 2. Let's do this very quickly. So therefore, where was this? This was the upper limit, so we'll go there. Sorry, the upper limit will go there, sorry. Upper limit will go there. And we do the last one. And then we've got 0.16 is equal to 2 minus x all squared to get the other one. And then take the square root of that. 0.16 is equal to 2 minus x. So therefore, it will be x is equal to 2 minus the square root of 0.16, like this. Yeah? And then is it not? Yeah, oh, it's plus or minus because we square root. But remember, what are we square rooting though? To be fair, yeah, that's a good question. Thank you very much for that, Kira. We have to be very meticulous, right? We're plus or minus because it's a square root, but we're dealing with height, aren't we? H was the height of the water. Height can be only be positive. That's why we're taking a positive one. Does that make sense? But thank you for putting that out. Yeah. Always remember in an exam, just be very meticulous for sure. Yeah. Okay. So putting this in now, this will give us 2 minus the square root of 0.16. And this gives us 8 over 5. Yeah. So x equals 8 over 5. Yeah. 8 over 5. So now we've fully transformed it all in terms of x. Yeah. Now we're just going to integrate. Yeah. Now with this one here, just a quick one. Sometimes you can get, if you notice, 1/2 is smaller than 8 over 5, but it's on the top. Why does that happen? Sometimes you can have that. There's a little trick, there's a little formula. I don't know if you need to know it for your specification now. This is an old past paper I got this from, but I have it here. There was something I wanted to just show you guys. I can't remember where I put it. Yeah, this here. Yeah. So it probably won't come up now, but if you ever see stuff like that, don't be confused or anything. It will be the exact same thing as if you were to take the minus sign off and just reverse the limits. Yeah. So just have that in mind. Just think I don't think it will. This is an old past paper I got it from where you had to remember that. But yeah, just to let you guys know. Yeah. So we're gonna continue. Yeah. Yeah, exactly. We flip limits and change sign. Yeah. Or you can even if you integrate like this, it's still fine. Yeah. So anyways, let me just make sure I've got this here. Yeah, this is all good. Okay, now let's just finish this off. So now, how do we integrate this though? We've got minus 80 plus 40x all divided by x. Anybody have any ideas how we integrate that? What do we do? Exactly, we separate our fraction. Exactly, yeah? So we're going to do minus 80 over x and then plus 40x over x. That'll just be 40, isn't it? Dx, yeah? And then half there, and then 8 over 5 like this. And then now this is fine now because this is going to be minus 80 ln x and then plus 40x, right? And now we just plug in our limits, half and then 8 over 5. And then what will happen is that the lower limit will give you a positive and the first one will give you the positive one. Can you use your calculator since it's a different integral? Would it matter because it's partial fractions or not partial fractions? Can you use your calculator? To be fair, when I did A-level maths, we had to do everything. So just double check with your teacher. In an exam for me, I would just plug it all in anyway. Yeah. Somebody asked if you could just put this into your calculator. I'm not even too sure, to be honest, because I don't really use the calculator that much, but potentially. But I would just, if I'm in an exam, just to be safe, I would just put this in. Yeah. Minus, and then it will be it will be minus 80, and then ln 8/5, and then plus 40, and then 8/5. Yeah. Okay. Now, just plugging this all in. Minus 80 ln/2, and then plus 20, and then plus 80 ln what is that? 8/5 plus whatever that is. 40/5 is 8. 8 times 8 is 64. Yeah, we just plug this all in. Yeah. 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 So I'm gonna put this all in now, and then this will give me the answer, hopefully. So just plug this all in, and then minus 80. Whoops, I need to get rid of that. Minus 80 ln/2. Got this here. And then plus 20, and then plus 80 ln/5, plus 80 ln/5. Sorry, not ln/5, ln of 8/5. 8/5. And then that is 64, right? 40 divided by 5. Yeah, that's 64. This gives me that there. And got this here. Let me just double check that's okay. Minus 80 ln/2 plus the 20. Yeah, that's fine. And then minus plus the 8/5. I'm just making sure this is all correct. And yeah, that should be fine. I'll just double check that because I feel like I've seen this question before and I've got a different answer to that. But yeah, let me just make sure. Is that okay though, that guys, overall? Should be minus 64. Let me just check. Yeah, exactly. Thank you very much. Exactly. I forgot to do the minus here. Yeah. Good thing I finished my A-levels, right? No, I'm joking. Thank you very much for that. So minus there. Yeah, perfect. Yeah, that's what I remember seeing. Yeah. 49 minutes. Did it ask for the nearest minute or anything like that? Let me just double check. Yeah, to the nearest minute. So 49 minutes. Perfect. Thank you very much, guys. It's a team effort, isn't it? Right? I'm teaching. Sometimes I can make a mistake. You guys are always there to support me. I appreciate it. Yeah. Good stuff. How do we feel though, overall about this? Happy if this comes up? Yeah. Okay, cool. Now, what I'm gonna do, because somebody asked to get this in a OneNote, do you not have to switch 1/2 and 8/1? So yeah, what I was saying, you don't have to. Remember this just quickly, because that could be a bit confusing, right? What you can do here, so this is the formula. You don't have to do it. Yeah, you get the same thing. So when you actually integrate it, when the limits aren't the right way around, you still get the correct answer anyway. But if I was to do this, for example, we started like this here. It was like this here. If I was to do this here, and then I was to do, for example, well, I want to flip this over. So I'm going to change the limits to 8/5, and I'm going to put this a half here. Now, if I flip the negative sign, then this will just become, it will be 80 minus the 40x, isn't it? Over x dx. Now, if I integrate this the exact same way, it will give me the exact same answer. You don't have to do it, but you can do. Yeah? Does that make sense? Yeah? Okay. Cool, yeah. Just as well, because a couple of people asked, let me just get the link to the OneNote, right? And you guys just let me know if it works. I'm just gonna get a link up. I've got a link for somebody that asked about the OneNote. Let me just get up here. Okay. So I've got a link. I'm gonna send it in the chat in 3, 2, 1, 0.50. Yeah. If you check the chat now, everyone, you should see something about OneDrive, blah, blah, blah. Yeah. Now I'm going to share my browser so you can see what that should look like if you go to it. So this is my browser now. You guys are able to see it. If you click on A-level maths, I have all of the questions that I've done here. If you go A-level maths webinar 11th of June, which is today, you should be able to access everything on your own. And obviously there was a lot of questions that obviously we didn't get to do. What you can do is just go to these here, go to these different folders. Yeah. Can you see? This is all of the work here. You see, this is all of the lesson plan today. I'm going to go back to OneNote because it's quicker. On the browser, it's quite slow. But yeah, On your browser, you should see all of these. I've got all of these questions here. A lot of them we didn't get to do. So what you can do is just have a look at these. Binomial expansion, I know is going to come. Didn't get time to do it, but I've got a question that you can try. I've got a couple of other questions here. And what I've also done as well is there's a student lessons tab. So these are just, I've made a folder with all of my students, my one-to-one students when I do classes with them. And there's just loads of different questions that we've done. Yeah, so there's loads of papers here. And yeah, you guys can access this and maybe just try questions. And I hope that's all okay for you guys. Is that okay? Did anybody check the link, by the way? Did it work? For question, yeah, good stuff, good stuff. But yeah, how are we feeling, guys, by the way? We ready to smash paper 2? All good? Any remaining visual advice? What do you think we should be doing? What I would say is, but depending on what example you're on, if there's any maybe topic lists or solutions or maybe sections of topics that haven't come up, revise that. Make sure you look at your specification as well. Yeah, that's actually a really good thing. Make sure you look at your specification as well for your exams. I've actually forgot to say that. So yeah, whatever exam board you're on, whether it's Edexcel, remember this is the Edexcel exam board. So what you want to do is you want to look through all of these, right? You want to say to yourself, there's nothing here that I do not know. Every single thing on this spec for Edexcel, you should know. It's the same for OCR. You go to your spec for OCR, read every single bullet point. Make sure you know everything there. There should be nothing there that should trip you up. And then for AQA, it's the exact same thing. I remember when I first did my A-level exams, I literally, before the exam, a couple of days before, I looked at the specification. I said to myself, there's nothing there that I do not know. There's nothing that they can throw at me and say, listen, what was that? I'm on Twitter tweeting about this question. No, you should know everything from your spec. Yeah. So I hope that's all clear. Hopefully, as long as there is a reverse chain rule, I was going to do that today. There's a reverse chain rule question I was going to do, but I didn't get time. But it's in the OneNote, so you can have a look at it. Can you send the link for the specifications in the chat, please? Yeah, I'll do that. Now, what I'll do actually, let me get that up again. Hold on one sec. Let me put this here. How do I share my screen again? Oh yeah. Oh, it's already shared. So this is for AQA. I'm gonna put all of them in the chat now. So this one is for AQA. That's in the chat. And then OCR, this is the one for it here. Put in the chat. And Edexcel, this one here. Copy this, put this in the chat as well. Yeah, so just make sure, guys, you know all of these very well. Whatever example you're on, make sure you go through all of these. You should say to yourself, there's nothing here that can trip me up. Remember that when you do the integration one, that one with the weird one with the limits, when they can express it as a limit. I'm just trying to look for it. Here, this one exactly right here. Recognize that this here can be written as that. So they can put this in an exam. Some people be like, what is that? Somebody said I had to integrate that. What? Well, yes, you did, because it's right here. It's there. Yeah. This is for Edexcel, but you guys get my point. Make sure you know everything. Yeah. Any other questions? We all okay? Just before I round up. Yeah. Okay. Cool. So guys, again, as I said, Tuesday, it's go time. Last pure maths, and then you got stats and mechanics the week after. I just want to say, well done to you guys. You guys are doing very well. I know you guys are going to smash it. Keep in contact. I'm really interested to hear how it goes, and I hope these pure sessions have been of benefit to you. Yeah. Have a good Sunday and good luck again. Take care. There's going to be a stats and mechanics stream. There should be. I'm gonna just double check my schedule, and I'll definitely let you guys know. Yeah. But yeah, guys, good luck. See you soon. Take care.